Hello, everyone. Welcome to the February 2025 DenverScript meetup. Glad to have you all here. Who here is it your first time attending? Wow, that's like half of us. Awesome. Well, welcome. First up, we have a code of conduct. This is the abridged version. If you want to see the full code of conduct, check out the website, denverscript.com/code-of-conduct. On the live stream, can you make sure that they can see my screen? Cool. So first up, DenverScript is dedicated to providing a harassment-free community for everyone. Participants violating these rules may be sanctioned or expelled from the community at the discretion of the DenverScript organizers. Your organizers are myself, I'm CJ, that's Cass. We also have Chad back there, and Marlena back there as well. So any issues arise or any questions for us, that's who we are. And if you are being harassed, notice that someone else is being harassed, or have any other concerns, please contact a DenverScript organizer immediately. If you're not comfortable doing it in person, denverscript@gmail.com, and we'll respond. Ground rules for tonight: please be kind. Do not talk over the organizers or the speakers. You all did a wonderful job of taking your seats at the beginning here, so I appreciate it. And during the talks, there will be Q&A. So we ask that you ask constructive questions. Don't try to prove a point or a gotcha. We're all here to learn, so be nice. And we are live, so youtube.com/@DenverScriptMeetup. That said, if you do ask a question, please wait for the wireless microphone, so that way the people that are watching at home, yeah, the spatula of talking, it's way back there. So be sure to wait for that so that the people watching at home can hear your question. Big thanks to our sponsor. So this space is Code Talent. They are a technical talent agency that knows the difference between Java and JavaScript. So if you are looking for a job or your company is looking to hire, these are the people that you want to talk to. It's code-talent.com. There's also some business cards running around, so definitely check them out because we appreciate them for giving us this space. And also thanks to jam.dev. They are bug reports that users love. So essentially you can add it to your site and users can report bugs back to them and you can triage them. So yeah, jam.dev. And also, there's going to be some after meetup networking at Rhino Beer Garden. It's generally in that direction, about half a mile. But the first round is brought to you by Sentry. So we're all going to walk over after if you'd like to join. And we're always looking for sponsors. So if you want to sponsor us, let us know at denverscript@gmail.com. And we're also always looking for speakers too. So we have a talk submission form at denverscript.com. Talks of any kind are welcome. If you've never talked before, that's okay. If you're a seasoned veteran, that's okay too. If you have an idea, maybe you're unsure, just submit and we'll work it out. So yeah, please submit talks. Next up is JavaScript news with Cass.
Hello, everyone. So lovely to see familiar faces and new faces tonight. Thanks for coming. News tonight. Let me jump over there. You can find our news on denverscript.com. There's a little tab on the top. Head over there. We've got news dating back since we restarted DenverScript. So if you're interested in anything that I'm about to gloss over, go there and you can find more information. Let's kick it off with some actual news items. For example, GitHub issues, like when you have a project board on GitHub, is now allowing nesting of issues. There's a cool little GIF here that you can check out. Nice. You can be a little bit more granular with your tasks now. Fabulous. There's a couple of other updates in there. Please feel free to check those out. Some cool stuff. Interop 2025 is being launched, so the browser teams get together and select a focus area and figure out how to make the stuff better for us developers. So check that out. There's a cool article on it from Mozilla. I am here for that. A lot of us probably spend a lot of our days hitting our head against a wall thanks to differences in various browsers, so that's always exciting to hear about. Next up, the Popover API is now baseline. This was like falsely announced last year sometime, but it's like for realsies now. So let's see. Baseline being like a standard that you can kind of trust to tell you whether things are supported or not that you want to use. So the Popover API is it's good to go if you're interested in finding more about the Popover API or even Baseline. Check out that link. We've got some new JavaScript stuff coming through. So 3 proposals are moving to stage 4, meaning that they're going to be put into the standard. So check out the article here on the new items that are coming soon. I don't know how long it takes for the actual standard to release, but check those out. Pretty cool. It's always exciting to get new stuff. And then Create React App is no longer around officially. A lot of us have already, I see some celebrations out there. A lot of us have already moved away from it, living the Vite life or whatever, but it's like been officially announced that it's being sunsetted. So check out the post on the React site, read a little bit more about that. And if you're in need of like, what do I do? Should I, like, do I migrate? How do I start my new app? This probably has some good information, but there's also some YouTube videos you should check out. Cool, and then next up, we've got some resources, learning, and articles. I encourage you to just come through here and click through these. I don't want to spend a ton of time going through them because we've got some great stuff coming up that I want you all to have energy and focus to listen for. But a couple things I want to call out, and I also have a question. Before I even say this, I want to know how you all pronounce this. Do you say temporal or temporal? Can I get a raise of hands for 1 is temporal, 2, ooh, yes, okay, 2 is temporal. Okay, maybe about half and half. A little bit more maybe on the second. Thank you. I have spent all day wondering how I would say it, so I'm just going to switch between the two. But yeah, this is really exciting. If you're a JavaScript dev, which I assume that you are, you have probably felt pain when working with the date system. And temporal, or temporal, whatever we want to go with, is aiming to replace that. So looks like it's coming. Read about it. Seems pretty exciting. And then another thing I want to call out, because I do this every time a new documentary comes out, we've got the Angular origin story coming out. So check that out. It's up on YouTube. Probably pretty good. I haven't watched it yet. Cool. And then if you've been here before, you know me, I like to harp on conferences. A really good way to find a new job or make friends, network, all that jazz is going to conferences and meetups. And I always like to say that as we in Denver spread out and share knowledge and information and community with everyone else, it makes Denver a stronger place. So I encourage you to check out this list, a couple ones that I want to call your attention to. Big Sky DevCon, it's not that far away. They have a call for proposals open, and you are all very capable of giving a talk. I am happy to coach, so is CJ, Ched, and Marlena are probably happy to coach as well. Please bug us if you're interested. Beer City Code, not so close by, but sounds cool. They also have CFPs open. Utah JS, not that far away. CFP's open again. Cascadia JS, probably really nice. CFP's open again. So I encourage y'all, if you want to submit, check out those. Ooh, also Rally. So lots of options coming up. Yeah, I think that's about it for news. A couple of releases out. I'm not going to walk through them, but please click those, check it out, see what's new in whatever tool you're using that's been recently updated. Yeah, I'll pass it back over to CJ.
Wonderful. So if you RSVP'd before yesterday, you probably saw that there was going to be a talk on React Native. Unfortunately, they stepped out. They might give that talk maybe in April. We'll see. So you get me instead. And today, we are going to be talking about Hono. Cool. Let me double check that the live stream's good to go, and then we'll get started. Cool, this is my break timer. We're just getting started, so let's take a quick stretch. Let's get ready to learn. Yeah. All right, so I'm going to be talking about a library called Hono, and this is going to be what I see as the modern way to build APIs. So, hello there, my name is CJ. Currently, I'm a senior creator at a place called Syntax, which is brought to you by Sentry. So, who here listens to the Syntax podcast? Cool. So, I am on the podcast every now and then, and they hired me about a year ago to make YouTube videos to go along with some of the podcast episodes. If you want to know more, syntax.fm, or check out Sentry at sentry.io. They are an error monitoring platform. So if you're running code in production, you can add Sentry to your app, and any errors that happen, you'll see those in a dashboard. You can triage them. You can see performance issues, stuff like that. So definitely check out Sentry as well. Also, I have my own YouTube channel called Coding Garden, where I live stream, which I haven't live streamed in a few months because I've been doing the syntax stuff. But when I do, I build apps live, I teach. You can learn more at coding.garden. That was me. Let's figure out who all of you are. So today we're going to learn about Hono. I like to think of it as like a modern version of Express. Who here has ever built an API with Express? Most people in here. So I do believe that most of what I'm going to show you will mostly make sense, but it's like Express, but modern. It's super type safe. It has all this stuff built in. It's really great. Okay, and also who here is like mainly a backend dev? Okay, just one person who here is like full stack, kind of bounce around. Okay, cool. So yeah, great. You all are primed and ready for this talk. And we will start with a simple Hono app. So you install Hono from npm, and then you can create an instance of a Hono app. Like I said, if you've ever built an Express API, this will look very familiar to you because we create our app and then we define an endpoint. So this says I would like to create an endpoint that responds to GET requests on the / route, and I'm going to respond with a JSON object that has a message property. And in this case, we're just exporting the app. So this is Hono, right? I mean, if you've used Express, it already makes sense, but there's just so much more that we can do and so much more that's built into it. And there are various packages that we can add onto it to get a really modern experience and create really well-documented and type-safe APIs. So first off, why should you choose Hono? It's super lightweight. It has 0 dependencies, and so it's really great for like serverless runtimes or environments where you're like memory constrained. So it's super small. Second, it's based on web standards. So everything is based on capital R request and capital R response. Those are the same things that you're dealing with when you deal with fetch. That is a web standard. Hono works in exactly the same way. You could think of your route handlers as a thing that takes in that capital R request object and then returns a capital R response object. So it's based on standards. And because of that, it's also multi-runtime. So, and this is one of the reasons I started to navigate towards Hono versus instead of using Express, because Express is built and meant to be used with Node.js. And some environments don't have full Node.js compatibility, but Hono apps can be run in Node, Dino, Bun, AWS Lambda, Cloudflare Workers, Fastly Compute. So all the places you could be running back in JavaScript, you can run your Hono apps. And its batteries included. I'll just scroll through like the middlewares and helpers section, but pretty much any middleware you could think of is built into Hono, which I really like, because when you're building things with Express, you typically have to find, okay, get my cores module for adding cores headers, or then I have to go find like maybe a body parsing module, or maybe I have to find like a cookie parsing module. You have to like assemble all this stuff. All this stuff is built into Hono. And lastly, it has really great developer experience. So it has first-class TypeScript support and a built-in RPC client. So you can build your APIs like you're used to, but then you can generate a fully typed client that your front-end codes can talk to and be fully typed and know about all the endpoints and types and everything else. So that's why Hono is great. And to create an app, we can just run this command. So let's do it. Everyone see that? So npm create Hono at latest, or using yarn or bun or whatever you want. It's basically like create Hono app. That'll create an app for you. You can give it a name. I'm going to call this example 2, and then you can choose your template. So when you start off, you choose where you're going to be deploying this thing to. And the thing is, for the most part, all the code you write is the same, and the only thing that differs is your server handler. But there are some differences if you're using like Cloudflare workers, because there are certain things that are only exposed to the Hono app on each incoming request versus being available all the time. So it's slightly different for that. All of that to say, we're going to use Node.js because we're just running locally. We can install dependencies, and that gives us a Hono app. But I have one that's ready to go just in case that didn't work. Let's take a tour of the app. So by default, it's set up with Typescript, so it has a TS config that's ready to go. And then we have our entry point here. And so just like we saw in the example, we're creating a Hono app, adding an endpoint. And then in this case, because we're using Node.js, we import serve from @hono/node server. So if you were using other things, I forget which ones, like Vercel, for instance, you would import serve from the @Vercel or @Hono/Vercel server. If you're using a more modern runtime, you don't have to import any serve. You can literally just export your app, because app has this fetch function on it. So things like Bun, Dino, Cloudflare workers, they all know what to do if they see a module that has a fetch function on it. So yeah, that's that. So this is your Hono app. I want to run through the docs and kind of like show you all the stuff that we can do. And for anybody that maybe doesn't know what an API is, let me show you what we get. So we go to localhost 3000. It responds with a nice little JSON object there. But we can define all other kinds of endpoints, right? We could say, when I go to /banana, I should get an object where the message is the banana emoji. Cool. And the dev server we're using here is just TSX with watch mode, so it's literally just running these TypeScript files. So it should have auto-refreshed, and now if I go to /banana, we get that endpoint. So this is codes we can write to make backend routes that respond to incoming requests. But what I want to show you now is the Hono docs, because they have absolutely everything you would want to know and do with Hono. So first up is the app itself and routing. So I showed you we could do get routes. We can do all the other things too. So you have post routes, put routes, delete routes, etc. And you'll notice here that the request handlers return c.some method, so c.text, c.json, c.html. And that's actually how you create the response that it will send back to the incoming request. You can see all of those methods on this page, like the text, JSON, HTML. And now we're going to see all the stuff that you get with Hono as well. So middlewares, if you're not familiar, are basically a way of having code run in between requests. So one example of a middleware is a logger. And you can add this middleware here, and then every single request that comes into your Hono app, it'll run through this thing, and you could do some logging however you want. Let's actually just create like a super basic logger right here. So I could do app.use, specify my handler. We get the context, and then we also get the next function to forward on to the next middleware in the stack or in the chain. So here I'm just going to await next. Right here I'm going to console log and just say incoming request, and we can just pick off things from the request context here. Like let's just grab the rec.path. And then also let's grab the rec.method. So I have my little request logger here. A request comes into my Hono app. I log what is the path, what is the method. When we await next, that allows my actual request handler to run. And then what's nice about this async way of working is I can actually log things after the request. You see, I await next, but here I could say like request complete. And maybe I give it some kind of like request ID. I'm going to disable my thing that keeps popping up because you can't see my codes. Just a second. Anybody know what it's called? Snippets? None. How about now? No. What is it? Is it IntelliSense? here's my break timer. It's been 10 minutes. So I'm not going to do much more live coding after this, but honestly, because of that, I'm not going to spend any time on it. Okay, set an ID when the request comes in, log the path and the method, and I guess we'll log the ID as well. After the request completes, log out the ID. So we now have our own little custom middleware here that's going to run for every request that comes into the app. And so if I request /banana, that made the request to the app, and if we look in the console, we can see there was an incoming request to banana, and then the request completed. We can also see that the browser made a request to like /favicon, because that's what browsers do, and we logged it there. So that's what a middleware is. It can basically tap into every request and do special things, and there are a ton of built-in middlewares in Hono, like the logger. There's a CORS middleware that automatically adds CORS headers. There's basic authentication, which will automatically pull the username and password off of the basic auth header. There's a bunch. And you can create your own custom middlewares like I showed, or you can use the built-in ones. If you just look on their site here, look at all these middlewares. There's cookie middlewares and GWT middlewares and things for static site generation and all kinds of stuff as well. There's a lot of built-in helpers too. So these are things that you would use in side requests, not necessarily a middleware. So like there's cookie helpers. So these automatically parse the incoming cookie headers to give you a nice way to work with cookies. There's a lot of other helpers here as well. One of the things that's great about Hono as well is just like built-in support for JSX. So the app actually comes pre-configured for it to use JSX here. So check this out. Let's actually rename our Hono app here to .tsx instead. And then I'll have to change the start command to use tsx, rerun it. But now we can use JSX inside of our Hono app here. So for instance, let's just say we had like a greeting component. Takes in a message. That message is a string. And then it just returns like an H1 that says, hello world. And I can't forget the fat arrow. So this might look like a React component. It actually is just a component that, I mean, I guess it could, in the context of React, it would be a React component. But this is a component that just returns some JSX. And if it's running inside of Hono, they just server-side render it. So if we set an endpoint here, there's a .html method on the context, and then I can just pass an instance of that greeting component. So here I could just say the message is hello world. So looks like React, but when I hit this endpoint, it's actually going to server-side render that component and then just return some HTML. So if I go to my app /hello world, and you look, it's just some HTML. That's cool to me because sometimes when you're building an API, maybe you need like an error page or something, and it needs some HTML that's not just JSON, and you can use the JSX that you know and love. There's way more to it. They even have like a client runtime, so you could create client components if you wanted to, but I like the idea of like super simple server-side rendering without having to set up like a view engine or anything like that. So yeah, client components, like I said, the testing experience is amazing. I'll show you some examples of that in a bigger app. And built-in validation. So this is one of the things that really sold me on Hono over using something like Express is when you're building a backend API, you want to validate incoming data, right? You have to. That is what we do when we're building backend apps. And they have validators built in. So for a specific endpoint, I can say, I want a validator for incoming form data, or incoming JSON body, or incoming query parameters. And then you can create a custom validator like this with just like custom logic, but they also have a Zod validator. So who here uses Zod? Yes, Zod is amazing. It is a schema validation tool for TypeScript. And so you can use Zod just like you know and love, but then use it to define the validators for the incoming body or incoming query parameters. So you could do it manually, but there is the Hono Zod validator middleware. So for instance, I could say when a post request comes into /posts, I'm going to validate the incoming form data with this Zod validator. And this right here will only ever run if this was valid. So you can actually add like an error handler in between that can like respond with the error message, and then you know that this code will never get hit unless it was validated. And so this is one of the things we're going to use to build like a modern API where everything's validated and also type safe. And there's an RPC. So we can define our endpoints like this using these typed validators, but the type of the actual Hono app, so you can see here, we're storing the creation of an endpoint in a variable. The actual type here is a type that can be used with Hono client to know everything about this particular endpoint. So we then have a fully typed way of calling this to know that, well, it's /posts, and it expects form data, and the form data should be in this format. So with the RPC, you can now use their client library, pass that type in, and you get a fully typed client. To me, this was awesome because it's like building out a little Express API, but now all of a sudden the types flow through to the front end. So this setup is really great for a mono repo where you have like a React app that can share the types with your API. You just import this type, and now you have a fully typed way of talking to the API. So yeah, that's built-in stuffs, helpers, and then here are all the built-in middlewares. There's things for like body limiting and cores and CSRF and JSON web token parsing, all the things you typically want to do in an API, all those middlewares are built in as well. So that was a whirlwind tour. I have a helper for it. I personally haven't used them. But yeah, check out the WebSocket helper. Essentially, you can add like your /WS endpoint, and then you have this helper here called upgrade WebSocket, and then 2 handlers on message and on close. So honestly, it looks kind of bare. So if you wanted like a socket IO experience, you'd have to probably build on top of this, but they at least have that helper. Yeah, I think there was another question. Right.
Yeah. Because when I see JSX, I want RSC. Is that on the horizon?
Possibly. So you've teed me up to talk about Hono X. So Hono X, wait, that could have weird results. Hono X is their meta framework that they launched, I think, last year. And the idea was to add like file-based routing and a bunch of other stuff on top of Hono. And so this gives you the experience of having pages and being able to create components with like a render function. As far as I know, I don't know if there's any RSC. We could probably search the issues, but this is where it would happen inside of Hono X. Let's see. This is, yeah, there's an issue with an enhancement, and the creator of Hono, so this is Yusuke Wada. He works on Hono, he works on this. So in May of last year, he's learning. So it's coming. Cool. Yeah. Sweet. Yeah.
I'm just curious if you've used HonoX and if you would use it potentially as like an alternative, like in a real app that you cared about. Would you actually use it?
I only spun up an app just to see what it was like. I have used Dino Fresh, if you've heard of that, but it seems like it's a similar experience because basically everything is server rendered. You can have islands, but there's no streaming built in yet or any of the stuff that you might get with like Next.js. I don't know, I almost feel like I would just use Hono with JSX components
framework?
or like JSX components every now and then. But I haven't tried to build anything substantial with it. So,
Thank you.
yeah, of course. All right, now for the good stuff. So that's Hono. That's all the stuff you can do with Hono. But in particular, when you're building APIs, one of the things you want to do is document those APIs. And so there's this specification called the Open API specification, not to be confused with OpenAI. I type that wrong all the time when I'm Googling it, but Open API, it's been around much longer. Who here has heard of Open API? A few of us? Essentially, it is a specification for how you can describe backend APIs. And the specification that you create describes all the endpoints in your backend. So it says, I will have a /users endpoint. It will respond to get. And when it responds with get, it's going to respond with this specific schema. I will have a post route for /users. It's been another 20 minutes, so let's take a quick stretch. Essentially, we can formally document our API to describe all the endpoints, what it takes in, what it returns, when it might error. And this is a standard that will work with any programming language. Essentially, once you have a spec, any language, whether it's Go or Rust or Python or C# or Java, they could implement that spec. And according to the client, they don't care what the backend is written in as long as it adheres to this particular spec. So that's the open API spec. And basically what we want to do is use Hono to build out an API that can adhere to that spec or automatically generate those specs. Another piece of this is automatic and interactive documentation. So who here has heard of Swagger UI? Most people, yeah. Swagger UI is actually built on top of OpenAPI. And I forget the lineage. I think OpenAPI literally just used to be called the Swagger spec, and they kind of like split it off. But you have probably seen a UI that looks like this. Not if you've seen something that looks like this before. This is Swagger UI. And this is automatically generated based on the OpenAPI specification. So this little endpoint right here actually describes the Swagger pet store with JSON. So it has all this info about like what this API is. It has what are the server endpoints. It has what are all the paths. So this API has like all of these paths. And then for like /pet, there's a put route for updating pets. There's a post route for creating pets. If I hit the post route, my request body is going to be validated to make sure that it adheres to the pet schema. So this is an OpenAPI spec, and when you plug it into Swagger UI, you get this UI that basically allows you to interact with that API and show all of the documentation. So there's that, and there's a new kid on the block, a more modern one called Scalar, and this is the one that we're going to use with Hono. Very similar to Swagger UI, but their automatic documentation also has, like, you can choose the programming language, like curl or Python, and it'll show examples of that you can copy and paste for all of the requests. It shows all the schemas and everything else. But ultimately, this open API spec, this JSON document here, you can also technically define it like with YAML, but this is the source of truth. It describes what the API can do. And then as long as you have an actual backend that adheres to this API, you can have clients that can talk to it. So that's the general world of documenting APIs. Let's talk about how we can do this with Hono. So first of all, we're going to use Zod. So we talked about Zod earlier. That's schema validation. So imagine this instance here with the pet store. We have a pet that has a name, a category, photo URLs, and tags. We could use Zod to describe this particular object to say it should have an ID, that's a number. It should have a name, that's a string. It should have a category, which is an object that has two properties. So we'll use Zod to define our schemas. And then there's another library called Hono Zod OpenAPI. So we can now take those schemas that were defined with Zod, plug them in to this library, which is essentially like a middleware. Well, actually, it's kind of a replacement for a Hono app, where we can now start to document our endpoints. And so the way this works is you'll install Hono, Zod, and this library, and then you can define all of your schemas. But this library also adds this .openAPI function on any of your Zod objects, so you can add these examples here. Examples, and then also defining like if it's in the path of the URL or whatever else. And so when you're looking at a Swagger UI like this is an example. And in their codes and docs, they actually plug that in. I mean, I guess if we looked at the spec for a pet, which is going to be under components and then schemas, there's probably a pet in here somewhere. And you can see for all of the pet's properties, it specifies example properties. So if we ever want to show an example of what that looks like, those show up. So this basically extends Zod to allow you to do that for all of your schemas. So yeah, define your schemas. Next up, we can create our route contracts. So this is built into Hono Zod OpenAPI, and essentially we define our endpoints in this way. So we can specify what's the method, what is the path, how should we validate the incoming request. So this is validating the incoming ID in the URL there using this Zod schema. And then we can document how does this endpoint respond. So for successful responses, it's going to respond with a user based on that user schema. And so this is, you can think of as the contract. This basically says, this is what my endpoint will do. Now we have to actually implement it. So you define the contract, and then you can define your routes. And so this is what I meant by it kind of replaces Hono. Instead of creating an instance of Hono, you create an instance of OpenAPI Hono. You pass in that route definition, and then the types actually flow through. So because we said that we're validating the incoming params in the URL, Now inside of my request handler, I can get access to those validated params. And you can also make it so that the code will never make it here unless that was actually validated. And then the types also flow through for our responses. So in this case, you can see that we're responding with the user that has these 3 properties with the 200 status code. And that's based on this spec that I defined here. So if I tried responding with like a 400 status code here, I would get a TypeScript error that says, hey, you're not adhering to the contract. And then after defining all your endpoints in this way, all of your API is documented at /doc. So that's that library, and then finally we can plug it into Scalar, which actually gives us the UI automatically. So this is what Scalar looks like. You just add the reference there, point it to the spec that OpenAPI generates, and you're off to the races. I also have this library that I wrote. It's called Stoker because it lets you stoke the flame. But it's just a bunch of extra middlewares and extra niceties that you might want to use when you're building out an app like this. So I probably have like 3 minutes left. Let me show you a real-world example combining all of this stuff together. And this is actually available on GitHub. It's called the Hono OpenAPI Starter. It is basically all of the stuff that I described, but with some examples kind of laid out to show you how to assemble this all together. So let me show you that now. And it all starts here. We have our entry point into our Hono app right here. And then we have all of our routes defined and we mount them up. But specifically, if we look in this folder here, this is a tasks API. Think of it like a to-do app. We can create tasks, update tasks, delete tasks, and it's all defined inside of here. So this is how we set everything up. We say these are the contracts that describe how the endpoints should work. These handlers are the implementation, and then all the types are flowing through. So if I actually bunked one of these up and tried to pass the wrong one to the wrong definition, I'm going to get a TypeScript error that says, hey, that does not adhere to that route definition that you have defined there. So that's one thing. You get type inference or the types flow through in that way. And then we can look at the actual route definitions here. So very similar to what I was showing in their docs. The only thing is I have a couple of helpers for my Stoker libraries, things like being able to use names for HTTP status codes, not having to specify application/JSON all the time with this, and then also the ability to create like error schemas. So there's that. And I'll also now show you the handler. So all of my route definitions are defined in here. This basically describes what are the endpoints, what can they do, what do they accept, what do they respond with. And then all of the types are exported here. And then I can use these types to actually define each of the handlers. So if we look in our handlers, for instance, we have this list route, list all tasks in the API. We've got some TypeScript going on here that says, hey, this handler should implement the list route, which is the route we defined in the other file. And the implementation is fairly simple here. Query the database, respond. But the types, like I said, are flowing through. So if I do some weird stuff and try to respond with something that isn't an array of tasks, I'm going to get a pretty bogus TypeScript error, but I think they're working on making these better. But ultimately, it's like, hey, you said that this was going to respond with a list of tasks, and you're not doing that. So the types flow through there. Similar for all the other endpoints, super low on time, but this code is available if you want to kind of like dive in. And I also made a video walkthrough on how I created all this stuff. One last thing I'll show you is sources of truth, right? So this is the other cool thing about this stack is all of this is database operations, right? We're reading from the database, we're writing to the database, and I want there to be a single source of truth. So for instance, if you look at break timer, but we're going to fly through it. If you look at this create route, it validates the incoming request. So this is a schema that validates an incoming task to make sure it has all the stuff it needs before putting it into the database. This is actually directly inferred from my Drizzle database schema. So I'm using Drizzle. I define my database table here. It's the source of truth. I can use Drizzle Zod to automatically get a Zod validator based on this database table. and everything just flows through. So later on, if I need to go update my schema, like change a type or add a property, all of that's just going to flow through to the inferred schema here that then flows through to my route definitions, that then flows through to my route handlers. And on top of that, Zod just has built-in ways of modifying the schema. So one of the things you typically want to do when defining an API like this is the insert schema is going to be slightly different than select, right? Because I don't want end users to specify the ID or the dates. Those are going to be auto-generated. So the schema for inserting really only cares about those two properties there. We can just use Zod. Basically, I say, create this schema, but omit those properties. So the incoming request only validates the ones that we want the end user to send. And on top of that, I can use Zod validators here as well. So in this case, I added a max of 500 characters on the name property here, but because this is Zod, I could use all the other validators, like is it a URL or is it an email? So it's a beautiful thing. The types, first we have our database table, that flows to the generated types. The types then flow into the route contract, and then those types flow into the handler definition. And I now realize I didn't actually start this thing up, so we have 1 minute left. I'll just show you what this looks like, and we'll call it. So if you go to /doc, this is the actual generated Open API spec, and all of this is automatically generated because I defined my routes with all of those helper functions. But you can see it defines the routes, the paths, it has all the schemas in here, and then /reference is the scalar documentation. So this is where I can see all of those endpoints. I can see what our success responses, error responses. I can see the examples here. And then within Scalar, you can also test these out. So like this is the create a task endpoint. So we could say finish talking. And that sends it to the API. You see the response here. So yeah, that's Scalar. I'm basically over time, but like I said, if you want a deeper dive and also check out the code, there's a YouTube video and then that repo. Check out hono.dev for all of their docs. These slides are on my GitHub as well, W3CJ. Thank you very much. No time for questions, but definitely head over to Rhino Beer Garden after this, and we can chat if you want to know more about Hono. So we're going to take a quick 2-3 minute break, grab some pizza, grab a drink, and we'll have Donnie.
Nice work. That was great. Okay, yeah.
check. So take your seats, finish up your conversations. We're getting started in 1 minute. 1 minute. All right. Your next speaker is Donnie Flood, who is a serial entrepreneur, a software artisan, and girl dad that loves to challenge the status quo. Most recently, he's a co-founder at fanstake.com, which is innovating the college NIL space. Today, he's going to be talking about Hotdogjs, a real-time multiplayer LiveView web framework at the speed of bun. Please put your hands together for Donnie Flood.
It's always fun to hear what you sent them as your bio, because I totally forgot about all that. It was great. I also want to say thanks to everyone for coming out and for CJ and crew for organizing this. Also, kudos to CJ. I love when people are passionate about something. It is obvious, and so it's so fun to see somebody with so much energy talking about something they love, especially types. So I'm going to talk about Hotdogjs. This is my little side project. We don't just high-level intro. This is experimental. It actually works really well. It's really fast. It basically the whole LiveView protocol it implements, but use it at your own risk for now. Would love to, if you do use it, give me feedback, all that stuff. So quick intro on Hotdogjs. It's a LiveView web framework optimized for Bun. Who here is using Bun every day or has used it? One couple people. Wow, I'm surprised. I think you should go play with it. Part of the reason I wrote this implementation of LiveView for Bun was because I wanted to learn more about the APIs that are available in Bun and just the power that came with this framework. It's really a great framework, or runtime, I should say, for JavaScript, TypeScript. I really enjoy it, and you should check it out. Who here knows what a LiveView is? Okay, that was basically no one. Which is awesome, because part of the reason I'm here is because I'm probably the only LiveView evangelist outside of Elixir and Phoenix. Has anyone heard of Elixir, Phoenix, LiveView? Okay, so Elixir has this framework that was based on Rails back in the day. It is called Phoenix, and Phoenix came up with this concept of LiveView. And I think about LiveView as a protocol. So I'm getting ahead of myself. So Hotdogjs is an implementation of LiveView on top of Bun. So freaking what? This is what the developers in Elixir land say about LiveView and the paradigm of programming LiveView applications. So this is a little long, but basically been using this for years. I couldn't be happier with it. It's a joy to work with. It has reinvigorated my love for web development. And that part in particular resonates with me. I want to be excited about working on projects every day. I want to love the code I'm writing and the framework I'm using. So that got me interested. With LiveView, the network gap between the client and the server dissolves. It's just magical. So as much as I love CJ's presentation on Hono, I've never used it. It looks great. The idea of having to write an API and a front-end application and keeping those in sync and all that stuff is felt like it's just so much effort. That was another quote that I thought resonated. And then this is the guy, Chris McCord, who actually invented LiveView. This is LiveView actually in Phoenix LiveView 1.0 just kind of got to 1.0 in December. But I think this is, again, part of the reason I was like drawn to this. Like I'm seeing quotes like this. This programming model still feels like cheating. Everything is super fast. Payloads are tiny. Latency is best in class. Not only do you write less code, there's simply less to think about when writing features. And so this is what people who are using LiveView every day are saying about this framework. So I think it's a really compelling, part of this impetus. Hopefully you're compelled to at least, get interested in what LiveView is doing. So I'm gonna go over some of the key features. Part of this is like building on top of Bun. Part of this is the LiveView protocol and paradigm in particular. Then we'll talk about the kind of anatomy of LiveView, and we'll go through a bunch of examples so you can hopefully get a feel by the end. So first of all, this is it's based on diffing server-side rendered code. So I guess I should have put a better diagram in here, but to take a step back, the way a LiveView works is when an HTTP request comes in, the server responds with HTML, right? Typical. That HTML code makes a connection to the server again through a WebSocket and sends events to the server through that WebSocket. And what it gets back are diffs of what's changed based on that event that went to the server. So every time a user interacts with your page, clicks a button, some event gets sent to the server, you're not re-rendering the whole page, you're not re-rendering part of the page, you're only rendering, and I can show you, the network protocol, but you're only re-rendering the state that has changed on that page. So it's a really smart way to keep your network, communication really small and fast. And that's automatic, by the way. You don't have to think about it as a developer. Two, it's real time. So again, like you are talking to a WebSocket live. You can push stuff up. You get things pushed to you. There's no thinking about how do I get this update that happened over here down to my server. It's really built in again to the paradigm of programming a LiveView. And the multiplayer we'll talk about as well, but basically, effectively, there is built-in pub sub in the protocol as well. So if and I'll show you some examples of this, but if your application needs collaboration, right, or it needs an event that happens over here to update somebody else's screen as they're looking at it, all that stuff is easy to do and built in to this framework. Simply yet powerful form validation. I think a lot about the things that we do all the time as developers, that should be easy. So form validation is sort of a classic one, right? And CJ talked about Zod, which is I have an implementation of form validation based on Zod here. It could be based on other validation frameworks, but I wanted to make it really easy for you as a developer. If you're wanting to validate a form, it should be super simple. You should just make it. You shouldn't have to what is the form validation library that I need to pull in, and I got to learn that API and apply it to my. This is just built in and easy. Also, one of those things that is annoyingly hard still, or you have to find a library that does this, is file uploads, drag and drop, progress, previews. All that is also built into this framework. And we'll show you an example of that. As I mentioned, one of the key differences here is the state management is in the server, right? So there's no state synchronization with your client, and how do I manage what's happening on my client across different clients? It's all happening on the server, and that actually makes your thought process, again, super easy. The routing is also based on server routing or traditional HTTP routing. There's no client routing here. So the way that the live views are defined is using file-based routing. So you'll again see how kind of straightforward the thinking is here. And then lastly, just as more of a bun advantage, but there's just built-in hot reloading and zero compilation for at least the server-side code. There is automatic compilation for client-side code, obviously a different target runtime. And so like all of these features for me were all about just like having fun, being productive, making this a, something I'm happy to do every day, happy to use every day. So let's talk about a LiveView interface. So this will probably be obvious, but every view has a render. The render is essentially what is the HTML I'm going to show on this page. We actually don't use JSX. We use a tag template literal HTML library, which actually makes the diffing super straightforward. But render is the method that every view implements and generates the HTML based on the state of the live view. Almost every live view, right, that is stateful has a handle event callback. So I mentioned before, all the events that are happening on the client, right, clicks, focus, form, input, all that stuff, those are shipped to your server automatically. And those arrive in the handle event function. So that's where you implement your business logic, right? And so you might get an event, it might have some data, you need to update the state of your live view based on that event typically, and then the render event is automatically called again when your state is updated. There may not be any change, so the diff may just come back empty, or it may be a very large diff, right? But you as a developer don't have to think about it. You just have to think about, okay, I'm getting this event, what's the business logic based on this event? And then the render happens automatically. There's another function, interface function called mount, which happens on one time when the live view is loaded. There are actually two different lifecycle steps, if you will, for live view. One is the HTTP request lifecycle, so there's one mount kind of called for that, and there's one called when the WebSocket is actually connected. And again, that's automatic for you. You just know, like, if I implement mount, this is going to be called one time, and you can, do all your setup and configuration, whatever you need to do within mount. Part of what you get there are any path parameters, any query parameters for your view, and any other event, data, kind of metadata you want to pass through, the URL itself, et cetera. Some live views that you'll see, we'll go through some examples. Have resources that they create. So it might be, a timer or, I don't know, open a database connection or whatever it is. So we also have a shutdown method that you can implement if you want to clean up your resources. Fairly straightforward, but this is again automatically called when your user leaves that live view or that instance of the live view goes away. And then lastly, there's a handle params method as well. This one, I don't think we'll show an example of this tonight, but this is what's called when query params on your URL in the browser change, or path changes, etc. So this is a way for you to handle, and patch back and forth kind of like parameters in the URL itself. So that's. Oops, I'm not used to having a microphone right in front of me. That is it. That's all of the methods that you as a developer need to know about when you're building a live view. Any questions so far? Is this making sense? Cool. Question?
Not a question, but it reminds me of like React sort of 2015. I don't know if you were a React guy, but it looks like very similar methods.
You'll see I actually use classes as well.
Sorry, just for people online, I said it reminds me of React sort of 2015.
Yep. The difference with React is that that's only client side, right? So this is actually you are running an app on the browser, right? But the events are being shipped back and forth, and the state is already on the server. So again, when you're thinking about so here's a slightly different view of the same code or the same information on the last slide. This is just the most basic, right, like counter implementation canonical example of any view that you might see. This is exactly how you would implement it in LiveView, right? So we've got a class. It extends this base view, which I don't know how many people use classes anymore, but this is how it works. We can set some types on the base view, so we get some good type auto completion around the code base. But what we're doing, again, like first thing we're doing is defining what state is in our class. So we have a count, it's a number, we're going to set it to 0. We can, we could, in the mount function itself, we could do any setup. We could actually leave that out if we want. And then the handle event, right, is handling an incoming event. That type is going to be increment, and we're going to update the count based on that. And we're going to render, the HTML, after that, right? So that's it. We'll go through kind of all the bindings next, but you can see where the button is defined, this HD-click. That's how you're defining, on a click, I want to send this event to my, to the handle event function. So that is like the most basic LiveView in existence. Any questions on this so far? Does this make sense? Yeah, there's some more questions. There's going to be a lot, like what I want to do as we continue forward is like go through a lot of examples. So hopefully this starts to make sense. Yeah.
I guess because we're talking about React, I'm just curious if you have some example of calling an API high would be the benefit between using React and using something like that.
What's the benefit of this versus React?
Like if you're using an API, I'm just curious, like you're fetching something.
I'm not sure I quite understand.
Let's just say you're accessing a database and you want to change whatever, I know React, it's a component, or you want to change the view. I'm just...
Can someone, I'm not sure I'm like getting the question. Sorry, yeah? Yes. So if you're hitting an API, the benefit of this, so I think so you're asking what's the benefit of this hitting an API versus calling an API directly from your React app. So for one, there's no cores here, right? There's no like worrying about like, can I actually call that? Two, there's no authentication necessary here either, right? So if you're making an API request call from inside your LiveView, you're actually doing that from your server, right? So there's no like, I gotta make sure I'm not exposing my API key to the client, or what is the JWT token, and does that have permit? Like, all of this is happening in your server. So when you're coming from React, this is it's like your mindset needs to shift from thinking about things running on the browser to thinking about things running in your server. Does that answer your question? Okay. Yeah. And I think that's like, I will say that's like a big shift just in mindset is like, okay, this is happening on the server. Go ahead.
Dovetail to my question.
Yep.
I keep trying to map this to a React component, but clearly this is a different unit of architecture.
Yep.
I'll keep it brief. So count is just in memory server state that's getting rendered to HTML on every turn.
100%.
Okay. Is this a lit component, or what is your HTML tagged template literal rendering library?
What is the HTML library? For the tag template literal?
Yeah.
It's just one that I wrote.
Wow. No flex.
Well, it does obviously escaping. In fact, one of the things that I was looking at was like, what does Bun's escape HTML do versus mine? Actually, mine's a little more safer, I guess. But what's interesting, the reason I need this, the reason I use this is in fact because the way diffing works. So when we're shipping back the diff over the wire, over the WebSocket, this allows us to actually like implement the protocol that LiveView speaks in. So one thing to note is the LiveView client library, what's actually on the browser page, right? That's running on your on your computer, is the same exact LiveView library that Phoenix LiveView is using, the Elixir side. So the way I think about this is like I've implemented a LiveView server that is a JavaScript or TypeScript server that's completely compatible with their library. So all of the security and other protocol updates that they add to the client, I just get for free. And all of the diffing, advantages that they have, I still need to figure out what they are and implement the, what that diff tree looks like. But once I figure that out, I get the benefits there as well. Does that make sense? Cool. So, I'll just kind of quickly go through some of the other bindings, right? So bindings are just hey, I want an event that, that's a click or a change or a key or whatever. So kind of the four main ones that I think about, 4 or 5 main ones that I think about are click events. Obviously, you have HD click, that's going to send an event name enc in this example to the server. Click away just means it's going to, when you click outside of that element, right, you're going to send that event. This HD value dash amount, so that you can pass additional basically key value pairs along with your event. So in the third example of the button with the click, there's the HD dash value amount. That just means along with the increment event that your server will get, you're going to pass an amount property with a value of 10 as well. The form we'll talk about as well, but basically when you want to track changes in a form element, form element and all the inputs, you just annotate that form with HT-change. That will, anytime an input is changed, it'll send an event to your server. Submit is anytime the button, the submit button gets applied, it'll send the save event, and it automatically sends all of the all the inputs in your form along and the data along with those events. We also have key events, obviously. So there's a key update, there's a window key down event. You can pass it the key up, whatever event name you want, along with the key that should drive that event happening. There's focus events, there's blur events, there's a bunch of other events, but these are sort of the main ones that kind of use on a day-to-day basis. Any questions here? Is this making sense? Anytime these types of events are happening, you're just shipping this event happened up to your server. It has all the state, right? It recalculates whatever, or you update the state, it recalculates the HTML, ships you back a diff, automatically applied. Cool. All right, so let's look at some more code. First of all, can you guys all see this? Is this? Let me actually. Okay. Yeah, that's pretty small. All right, let me close this. Maybe I'll do what. Maybe we'll look at it this way. Might be easier for some reason. Okay. So this is the Hotdogjs repo. One of the benefits of Bun, as I'm talking about the benefits, it supports mono repo kind of by default. So if you want to play with these events, please clone this repo. You can go to the examples package, and all the code is kind of under the examples package. There's lots of examples in here. Go ahead. Oh yeah, I'm sorry, I meant to do that. Okay. So we're gonna look at the counter example that I showed you earlier, right? This one's slightly more code. Is this better, I guess, from a? Okay. So this is a little bit more code than I showed you last time, but basically, again, we've got our internal state, right? We've got a count. Don't worry about the layout for now. I'll skip the mount. So we've got a little bit more, obviously, CSS here, but we effectively have our button. We have a click event or click binding with a decrement and an increment. Those are going to ship to our handle event code, right? And they're just going to update our internal state count. That'll cause the re-render. So if we actually go to some examples here, this is the counter code that we were just looking at, right? So it's pretty straightforward. It's obviously local. But even if we were running this over, on a server remotely, it's really fast still, because we're only shipping. Actually, do you guys want to look at the wire protocol real quick? Cool. Got to reload so I can get it. Okay, so let's zoom in here. I'm not used to zooming in this much. How do I even make it bigger? All right. So this is kind of the join callback and reply. So we're actually going to click on that button, and we're just going to see right here. I don't know how well you guys can see that, but basically, where is it? Here we go. This is what shipped back, which is this response diff, which basically is 1, right? So it's the 0th element in the tree. Nothing much changes except for this one thing. As we click more on those buttons, I'll find this somewhere. Gosh, this is harder than I thought. But we're up to 4 now, so you can see the thing that was changed was just a 4. So again, you're as a developer, you don't have to think about any of this diff, any of the WebSocket connection, anything like that. You're literally updating, this is your implementation here, right? And it's automatically sending back the fact that this count here has changed. And that's the only thing really in this whole HTML body that can change. So that's the only thing it's shipping back. So that's the most basic example. Not really that cool, I guess, but kind of cool. So let's go back to our examples here. So what's another one? So let's do keyboard navigation. So this is another example of a LiveView. So I'm using JK for up and down, and then X for select. So I don't know if you guys use Gmail by keyboard shortcuts, but that's where I got that. So this is a really basic example of hey, I'm selecting some stuff from a list using keys, and the only thing I can that's let's look at that code. So we're back in examples, source, pages. Sorry, toppings is what it's called. So we've got a definition of the events that we can get. Basically, the type is going to be key update, and the keys can be one of these 3 keys. This is just my hard-coded list of toppings. This is my let's go to the the HTML. So all of this is basically static except for this map, right, showing the elements. And so that's really the only thing that's going to possibly change, right, is some code around this. Where is the keys? So the keyboard binding is here, right? So we've got this KBD element. It's got a HD window key down binding that's going to ship this key update event along with the key that's being pressed. And then in our handle event interface, we're actually look for that event and handle it. So that's handling keyboard input. Any questions there? Kind of makes sense, right? It's pretty straightforward. You guys are good. CJ.
Check. So not about this specifically, but I'm just starting to click now. But I'm curious. Maybe you mentioned it. Does every socket connection get on the back end have its own instance of this class? So each one gets its separate state for different clients connected?
Correct.
Okay.
Yeah. So every instance of the WebSocket essentially has in memory, right, your state, and that all of the events are shipped back to that WebSocket, and to that in memory server. More questions? Yep. Yeah.
Hello? Okay. Yeah, Safari. Wow. Okay. Follow up on that is just do servers that are running this sort of architecture typically need to be more memory powerful, or is Is there some trade-off that way?
Yeah, I mean, it depends on your application, your web view, or your live views, all that stuff. Yes, I would say, but it's still really small, right? You're talking about well, in our other example, right, it was like one counter, right, that is a number so what's that, like super, super tiny. There's a little bit of overhead around like the diff, keeping track of the diff tree as well. But it's relatively small. And a lot of the time you end up talking directly to a database, right? You're like, I'm saving this task, I'm querying this task list. And so your state is already on the server, mostly persisted in your database. Some of it might be in memory here, but it's generally shipped off to your database if you want to persist it, right? Or shipped off to some other durable queue or blah, blah, blah. So you're really often not like doing much more on the server than you would otherwise, especially compared to, an equivalent, again, like the thing I think about that this doesn't have is like, I don't have an API that I have to build here, right? That I have to run separate from my application. So anyway, I would say not more than your API server either. So yeah, another question.
Yeah, piggybacking off of the WebSocket questions, how does this handle things like polling, dropped connections, drop sockets, et cetera,
Good question.
reestablishing? And then the second part of that would be, is it possible for cross-socket communication, like multi-user communication?
Definitely. So in the so this is experimental, right? There is automatic built-in retries on the client side of the WebSocket handler. So what's running on the client, if it loses its connection, it'll try to reconnect automatically to your server. Obviously, you might lose some if it's in memory, right? And the instance of my counter LiveView, is now a new instance because I got a new connection from a socket. I'm going to lose that. If your data's persisted in the database, right, and it's just, I'm the same user and I should have access to all my own data in the database, you've effectively lost nothing. That is maybe the one potential downside of LiveView is it's, if you're in a low network connectivity area, right, which is increasingly small, it may not be the best. But if you're talking about any app that's running in most places, I think you're not going to have that dropped connection problem, especially if you're persisting your data to somewhere, right? Does that make sense? Cool. So let's talk about, so we saw the counter example. I have a pub sub counter example as well, right? So we're going to open up 2 tabs here. So these 2 tabs are pub subbed. So I'm going to just click here. It's already updated there, right? I'm going to down here. So this is an example of, I mentioned the built-in pub sub capability of LiveView, and in my implementation, it's actually it's based on broadcast channels in the server. So those are obviously not persisted across server restarts, but theoretically, and I've implemented it in another place, you could have a Redis powered pub sub or SQS or SNS or whatever, or any other queuing backend that you want. And so let's look at this code real quick on the difference between that counter and the pub sub counter. So this is the pub sub counter. What I actually do in this case is I'm just extending the counter that we looked at before, right? So it's actually the class that we looked at that was just the non-pub sub counter. It's that class that I'm extending with my pub sub counter. So it's calling the constructor. In this case, the mount is slightly different. So there is this. I'm not going to go over this too much, but one of the things you get passed into all these interface methods or your LiveView methods is this context. The view context has a bunch of helper methods on them. One of the methods is called subscribe. And so you can just pass in like, I want to subscribe to events that are named this. And the ctx.connected just means that the WebSocket is connected. So if you're rendering this, the first time you render this over HTML or HTTP, this will not be connected because it's an HTTP request. Once the WebSocket connects, this ctx connected will be true. And so you don't want to subscribe to events that aren't going to happen. So I'm just subscribing to a count change event here when the LiveView is mounted. And then I'm listening for count change events as well in this handle event. Everything else is basically the same. So this super handle event is just calling out to the other code. And anytime I'm not receiving a count change event, so I'm not receiving something from the from the publisher of that event, I'm just going to publish my own. Right? It's got to be something else. It's got to be an increment or a decrement. So once that happens in the handle event from my, from the class I'm inheriting from, I'm just going to call publish with, my own change. So this is, this isn't, there can be some conflicts. This isn't a conflict-free, whatever data structure, but you could easily put that in here as well. So that's kind of how the just like multiplayer part of this works out of the box. Any questions on that? I know we kind of like went kind of fast there, but does this make sense? Yeah.
So like that would be a good spot where like, let's say you were making a messaging app, that would be where you're like, let me write this message to the database, then broadcast it to anyone subscribing to
100%.
this component.
100%.
That's sweet.
Sorry, I have a lot of questions.
I
I'll
love
try
it.
to limit them.
Yeah.
Each new tab creates a new instance of a WebSocket.
Correct.
Is there anything like service workers to limit the number of connections per like browser window or anything like that?
I don't know how I haven't written the JavaScript client code, so I don't know exactly how that works. I just know the protocol, honestly. So it's a good question, and we can look. I mean, it's open source. We could look at that and figure it out. But I don't know the answer to that one. It's a good question.
What kind of conflict resolution does it have if there are two, let's say, writes to the same?
Yeah, it's a race condition, right? So if you wanted to use like a, YJS, right, or something that actually implements conflict-free, whatever, data structures, right? You would want to use that, but this gives you the like hooks to do that in a pretty straightforward way. So again, like if you're subscribing to that event, and instead of this here, where we're just like setting the count to the count we got, you're running it through YJS's, doc or map or whatever the right, data structure is for your use case. You're done at that point, right? So yeah, this doesn't like manage that. It's more of like it's just a queue, right? So there could be some race conditions, but that's. I thought about putting YJS example in here, and I'll probably add one at some point. But does that seem fair?
Oh yeah.
Cool.
No, that's super in the details. I wouldn't expect you to have to write that. But
no worries.
Cool.
Okay, so what do? We did counter. We did pub sub. Okay, let's do the form stuff. So, okay, how do we navigate around here? All right, so where is it? Where did I put it? Oh, yeah, form register. So if we go back to let's show you the example. All right, so this is, classic example of like just a registration form, right? I put in my email at blah, and then I hit, tab. This, automatically sent the fact that I updated this input to the server. It ran the validations and said, hey, that's not a valid email, so let's fix that. So let's type a username. Oh, it needs to be 4 characters. Okay. Let's do like password. I'm just gonna do 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 5. passwords don't match, right? So that's really easy. Let's look at the code now. So let's change that to 6. So then it should match. And then we can hit save. So then we have a modal. And by the way, this modal was actually open from a server, from the server. So that's kind of cool. So you can see, we've got, the username, your email, blah, right? So pretty straightforward example. Everybody needs forms and input. So going back to Zod, thanks CJ for setting me up here. So the way the form kind of validation library works is we define a schema, right, which is using the Zod kind of definition. So we have an email, it needs to be an email, username, password, right? They need to be a minimum of 4 characters or 6 characters. This kind of section here makes sure the passwords match. That's our kind of like test case there. With Zod, you can infer, basically given a schema like this, you can infer a type. So this is the inferring the kind of a type from the registration schema that I defined above. And then I always define these events. Like events are basically what can come into my, what my handler or my event handler should be able to support. So I've got, a save event that's going to come in and a validation event that can come in, and both of them will, will have the registration data as part of their, part of the type item that's going to come in. So in my register view class, right, I'm going to define this form that is a registration type that we talked about before. It's going to use the Zod form library that I implemented. Theoretically, again, we could use other types. This is the modal I showed you. Let's see. Let's look at some HTML. So lots of this is just Tailwind stuff. So we have a form helper built into LiveView.js, which again does some type safety checks for you. So this, we're passing in the registration events. That knows that the types of events that can be sent back to the event handler are named save and validate. So if I were in my IDE and I changed validate to like a typo, validate without an E, it would give me a type error here and say that's not an expected event type here. So then I've got some helper components here, but effectively you can think about this as like, actually, should I go, where is that? That's down here somewhere. Okay. So anyway, there's lots of helper events here. I'm getting too far in the weeds. At a high level, the way you should think about this is we've got a form. When we hit submit, we're going to send the save event, or we're going to send the save event up to the server. Anytime anything input changes on that on any of the inputs, we're going to send the validate event. And then we have our handle event method here again, which either gets a validate event, which we call our Zod form update, which passes all of the data in from that event and automatically binds it back to the form itself. I'm not explaining this very well. All the magic here is that all of these helpers work together in a type safe way to run your anything you submit to this through this form through Zod, run the validator, and automatically give you the errors based on the validation, whether it's successful or not. So the same function. So we always call update to validate and get the the errors back and apply those in our render function below. In the case of a save, we also call the update because we still want to validate it. And in this case, we could save to the database here, right? So when this form is valid, that will be true. So we would, in this case, we would usually save to the database. Here, we're just sending back a modal through this context push event. So that's kind of, I don't know, maybe not the best explanation, but it's really easy to, again, define your schema for your form and then get easy error validation and error rendering with some of the helpers that, with the form helper and the input helpers that I've built in this library. So I should probably do like a a side documentation on this, but the idea is it should be really easy for you to use this. Any questions on the form validation? That wasn't my best job, but it is what it is. Cool. Okay, let's show you one more. All right, two more. So let's do a like a timer kind of thing. So let's show you a dashboard. So this is an example of, let's say you have, I don't know, some e-commerce store, right? And you want a dashboard where you're like looking, you're getting like what's happening this second. Oh, I've got 16 items in the cart. This is how many sales that happen. This is the average rating. So this is an example of like, a dashboard. If you hit refresh, it just, refreshes faster than every second. So this is pretty straightforward. This kind of thing is pretty straightforward as well. So we've got a dashboard here. The only event that we're getting here is refresh. This one uses a timer, right? And so in our mount function, if we're connected over the WebSocket, we're going to create a timer, and every second we're going to dispatch a refresh event, right? And so the idea is like, you have something running in your server, right? This is LiveView is running your server that every second is going to send itself an event to the handle event function. So whenever handle event gets a refresh, in this case I'm just like generating random data, but you could imagine like looking at your database, running a query, whatever you want to do, updating our local state, and then rendering that state based on the changes. So that's how easy it is to sort of like push live data back down to your view, right? Like this is literally, this timer, is running on the server. Again, we're just like, we're just generating things randomly, but you could imagine it querying a database, and then since your live view has been, the state has changed, it's pushing every change back down over that network connection. So if we look at that connection, again in here, you can see it's being updated all the time. And you can see sometimes there'll be, less diffs than you expect because, it randomly generated the same number, right? And so it's a good way to kind of look at like, as you're seeing the diff come across, like what's actually being changed on the page. So that's a live kind of example there. What were the other ones I want to show? Oh, we should do photos. So last one I'll do is photos, and then we can ask questions, talk about questions. So photos. Let's go back here. Where's our photo? Oh, I also did an AI chat one, but whatever. Okay, so photos. So, like uploading photos or files is something that, again, most apps need at some point. It's, to me, really hard, to find library. Now I got to learn this. Is this the right code? So I wanted to make it easy. So I'm just going to just show you drag and drop here real quick. So we can drag some files there. You can, obviously the styling is you got to add, but the fact that we can show previews is built in. The part where we can I hit upload and it shows you the progress as you're uploading the images is very easy to connect into. And so I just uploaded these photos with this app really, really easily. The drag and drop is also built in. In this case, I can like my my images. The other thing that, and I'll show you the code here in a sec, but we also have an S3 example. So you can choose files. So let's see, this is the binding that I uploaded. So this is actually uploading directly to S3, not through your server, but directly to the to S3 as well. So that's kind of cool. Let's look at those examples real quick. So these are a little bit, so maybe I won't go through these in too much detail because I want to leave some time for questions, but effectively what we can do is like define a configuration for what we want to upload. We can tell it we only want to allow photos or or whatever, PDFs or whatever it is. We can limit the number of entries we want to accept, the file size, and maybe I'll leave this as a something for you guys to look at. But effectively, like this is really this is also something that's really easy to build and to use. So I'll just show you the save event. So we get, as part of our context, we get the uploaded entries for, why is this open here? For the upload config that we registered in our mount. So the upload config is that's just an ID. It's just a name in this case. Where is it? Yeah, it's just called photos. So we say we're going to allow uploads with this config ID, with this configuration that we defined up here, and then when these entries are actually, when we save them, when the form is being saved, we get them automatically in our context, and we can basically consume these entries. In this case, I am saving it to a database, which is why you saw it when I loaded the page. And this one is also pub sub just for you guys. So if I actually which one is this? The photos one, yeah. So if I went to another photos page and I uploaded something else, I don't know, what's an example here? Here's another, what is this one, screenshot? Okay, we'll see what it is. So if I upload this here, this should show up here. So there you go. So cool. All right, so I want to save time for questions, and we have like 5 minutes technically left, but I'm happy to answer more questions at the after party as well. So yeah, lots of other examples in the code as well. So would love for you to check them out and run them. Yep.
It's a great talk. I really liked the demo. As you were demoing, I got, I think, a better understanding of what's going on.
Yep.
And is it fair to say that after your first interaction, it's not actually server rendered, and LiveView client just knows how to patch those diffs right on the DOM?
Yeah, it's server rendered in the sense that the server knows what it showed you before, and it can, once it recalculates what it should show you again based on the state update, it runs a diff against what it previously showed you and then can ship back those changes. So and it's also server rendered on the HTTP first request. So it's, but yes, that's I think part of the magic of LiveView is it's, shipping back only those, small parts that are changing, for sure.
Thank you.
Yeah.
Yeah, I was just wondering, is there any case where you're like, damn, we're missing using this user's powerful local machine to do anything, or is it basically only for a very unique case maybe?
It's a good question. I guess for me, I'm less worried about using somebody else's machine or their, to the best, outcome versus how productive am I and how easy is it for me to do something else, right? Add a new feature, make their experience better, and so yeah, I guess that's the way I think about what I'm optimizing for here.
That bottom line probably outweighs it.
Yeah, that's how I think about it.
Sure.
Yeah, I mean, you shouldn't do video editing over LiveView probably, but maybe you can do AI streaming, which that's another example in here. Yeah.
Is there anything about the LiveView protocol specifically that you were very allured to, as opposed to just trying to implement a more server-driven style of coding in a already existing front-end framework or something like that?
I mean, yeah, the diff part of it to me is really compelling. Mm-hmm. So I would say, the wire protocol to me is pretty genius. Also on the, when you're uploading, images, right? That's all going over the socket as well, and so that's a binary format that's really compact and smart. But I think the thing that is most compelling, at least for me, was more of the paradigm from a programmer perspective.
That makes sense.
Just like I am writing one file, right? That is both server and client together, and all the hard stuff, like, God, it's hard to connect to a WebSocket, right? It's hard to like ship things over that WebSocket in a consistent way. So my client, like all the hard things are figured out because the protocol exists. So all you have to do as a developer is think about, hey, when this thing happens, I need to know about it. And when that thing happens, I'm gonna update this thing. What's gonna, the view's gonna change. Like, that's all you need to think about. You don't need to think about like, okay, what is my GraphQL query for this thing, right? And also I've got to implement the GraphQL query myself, right? Like, I've got to know what to call in the client. I've got to implement it. Like, is this secure? I don't know. So I think just going back to what Chris said, right? Like, the like paradigm is just so powerful for me. Again, like, I'm not saying you should all use this every day. You probably, if it's a static site, you probably shouldn't use this, right? But most like true applications involve state change, right? And making it easy to get your state, like changed and your view updated without having to overcomplicate things is, I don't know, that's like satisfying for me. That's where my passion comes from, going back to CJ,
That's awesome. Thank you.
Yeah.
Appreciate it.
All right. That's all we have time for. So thank you so much, Donnie. This was great.